So 6.3c, we've got the square root of a perfect square, which is bottom of page 518, top of page 519. This is just going to be a little short section. But remember when we had the square root of something like x squared? That meant that this number here was the same as this number here, which means the square root sign could go off. Okay, so let's say, for example, that we had, instead of an x, let's say that we had a 3. So that means that the radical sign and the exponent go away and we have just 3. Or if we were to actually do the math, we would get the square root of 9, which is 3, correct? But what if we had negative 3 and we squared it? Negative 3 squared is 9, which is 3. So we get the same answer regardless of whether our number is a positive 3 or a negative 3. So let's just pretend that, well, not pretend, let's just say that when we take the square root of, say, x squared, like here at the top, that is equal to the absolute value of x. It means that no matter if this is a negative or a positive number, when we square it, take the square root of it, we're going to get a positive number. So that means that if the number is a positive, we get a positive. If it's a negative, we get a positive. So that's what this property right here, which is top of page 519. If we know that, let's look at the one we've just got here. If we know that this number is positive, then we're going to take off the sign and we're going to have a positive number. If we know that this is negative, if this number is negative, then the square root of that with a negative sign, which would be this, is going to be the absolute value of 3. So no matter what, we know that it's going to be a positive number. So if we don't know whether this number is positive or negative because it's written as that, we don't know if it's positive or negative. So if we don't know, then it's going to be the absolute value of x. So if it's negative, we're getting the absolute value of x. If it's positive, so we're going to get a positive number either way. Which means when we have 9x squared, well, I know that the square root of 9 is 3, but I don't know if x is a positive or a negative number. So because I don't know if it's positive or negative, I'm going to say that it's going to be the absolute value of whatever x is, positive or negative. It's going to be the positive number of whatever this is. Okay, so because this is a 2 and this is a 2, everything comes off, the sign and the exponent here. If I had something like the cubed root of x, because it's an odd root, the index is that means we get, I'm going to write this differently. That's going to be confusing. I'm going to write it as the square root of x cubed. So because that's a 2, 2 goes into 3 one time with 1x left over. So when I pull that x out, I put I put absolute values on it to show that no matter what, this x is going to be a positive number. So as you're doing these, don't let these get confusing to you, because pretty soon we'll end up taking that absolute value sign. I don't know why my brain just kind of quit working. That absolute value sign will disappear. But right now they're just trying to make sure that you realize that whenever you take the square root of a number and square it like that, it's going to give you the positive number. In fact, later on, maybe they will give you this word. I don't know if they will or not. The principal root, which basically means the square root of a number. We're pretty much basically going to look at it as just being a positive answer. But they just want you to be aware that if there's a negative number in here and you're squaring it and you take off all of the signs, you're not going to get -9. You're going to get a positive 9. Okay, so that's just very important to understand because, when we remember when we did 1 over the square root of 3, we multiplied the top and bottom by the square root of 3 over the square root of 3, and we got square root of 3 over, and I said that'd be 3 squared. And I said whenever you have that, you just take off all of the stuff around it and you're good to go. Well, that works perfect unless this number is a negative. And then you've got this -3 here, and you aren't going to. You change it to a positive. So hopefully that'll help you. Now when you've got an odd root or an odd number for an index, and we've got -2 and we've got a cubed, things are a little bit different because -2 cubed is -8. And a number multiplied by itself 3 times is going to give you +4 times -2 is -8. So that's how we get a -2 for our answer. So even though we've got a negative under here, we don't take the absolute value of it if the exponent and the root are odd numbers. If they're even numbers, it will be positive. If it's odd, it's going to be the same sign as it is down here. So anyway, not much information on that. I don't remember if there's much on the homework over that. Might be a few problems on that when you're at number 71. I guess you've got 3 problems from 71 to 81. 73, 77, and 81. Just remember to use your absolute value signs as you do that. So just real quickly, I want to look at number 13 because I noticed there is a homework lesson with one similar to this. So they've got a trinomial under here, and you pretty much just pretend that radical sign doesn't exist, and you just factor it into your 2 binomials, x minus 3, x minus 3, and that equals x minus 3, the quantity squared. So now see, I've got a squared sign there, and I have a 2 there. So that means the sign can disappear, but I have to tell the reader that it's positive. So I put the absolute value sign there. Same is true with like number 14, where I have x cubed minus 5x squared, and it's under a square root sign. And what do I get here? I can look at this and factor out an x squared, and I'm left with an x minus 5 in the parentheses. So all I did was looked at this here, factored out an x squared, and have what I have left. Okay, so the square root of x squared would pull this out and make it an absolute value, and then I'd have x minus 5 left in the radical sign because I didn't do anything to simplify that. There's no exponent on this in order to take it out. But because 2 goes into 2 once, I can pull 1x out, but I have to put the absolute value sign on there to show that this number is automatically going to be positive because it had to be positive under there. Okay, so that's it for 6.3.